Alright, so this is a tutorial for Chapter 5 assignment, Lesson 3. For those of you who are working on calculating surface area of cylinders and cones, I'm going to walk you through the first few questions on this assignment, so hopefully you get a better understanding. The first thing I want you to pay attention to here are these two formulas. One is for the surface area of a cylinder, and one is for the surface area of a cone. Now, as we make our way down to question 19, you'll see it's a matching question, where we have 4 shapes on the left-hand side, and we also have 4 nets on the right-hand side. So now we need to try to think about which of these nets is connected to each shape. And as you can see, the pyramid is very easy to pick out with all the triangles. We have a cylinder, cone, etc. And essentially, this is what your answer should look like for question 19. Now, as we move on to question 20 here, one thing I really want to note is that we're calculating surface area, which is always measured in units squared. So think of carpet in a bedroom or hardwood flooring. We always measure it in square feet or square centimeters. And in this question, we're calculating surface area of a cone using millimeters squared. So as you can see on the right here, we're given 2 measurements for the cone. We are given a slant height measurement along with the radius of the circle. So we're going to use the surface area of a cone formula, which is marked by SA for surface area. This is the same formula that was found on the previous page. Next, we're going to try to plug in these values, the 6 millimeters and 4 millimeters, into our formula. So the second step of our equation should look something like this. Pi times 4 millimeters squared plus pi times 4 millimeters times 6 millimeters. And it's very important that you follow your order of operations, bed mass, in order to complete these calculations. And you should end up with a surface area of 126 millimeters squared. While you're doing the calculation, the second line of your equation should be done one section at a time. So first you'll calculate 4 squared, which is 4 times 4. So we have 16 times pi, and that will be your first section. And then you'll have your second section, which is simply pi times 4 times 6. Now, if you can't remember what this pi number is, it's actually just 3.14, or you may even have a pi function on your calculator. Now, as we move to question 21, we'll be looking to find the surface area of a cylinder to the nearest meter squared. And again, we've been given 2 measurements here. We have an 8 centimeter and a 16 centimeter. The 8 centimeters is for the diameter of the circle, and the 16 centimeters is for the height of the cylinder. So we'll be using the same surface area formula from the first page, broken down in 2 sections. We have 2 pi r squared, which is going to basically do the area of the top and the bottom circle. You can't see the bottom circle in this picture though. And then the 2 pi r h is going to be the calculation for the outside of the cylinder. Now, as we plug these values into our formula, we should have something that looks like this. 2 times pi times 4 meters squared plus 2 times pi times 4 times 16. Now, once we crunch all those numbers, you should end up with a number of 503 meters squared. As we move on to the next question, question number 22, we'll be looking to find the surface area of the square pyramid to the nearest foot squared. So the first thing we're going to do is calculate the base of the pyramid, which is simply side squared. So we have 5 times 5, and that's going to give us the area of the bottom of the pyramid. Then we're going to add 4 1/2 times base times height, which is going to give us the surface area for each of the 4 triangles that are all equal to each other. Now, if you're having trouble with this, you can use 0.5 times the base, which is 5 centimeters, times the height, which is 10 centimeters. Once we plug all these values into the formula, you should get a giant formula that looks like this. Again, broken into 2 sections, one for the square base on the bottom, and 4 times all 4 triangular side areas. And we should end up with a final surface area of 125 feet squared. I hope this tutorial has helped you with this assignment, and if you have any questions, please don't hesitate to call or email me.